Good day and welcome to Sverchok next tutorial. Now we will improvisation in Sverchok. So I want to make plant of tubes with different lengths, and it will look like this. Plant tubes, they make waves in the tops, and we will make table with column and length of tubes that we can assemble in simple way after all in fabrication. So we get Sverchok. First of all, some people asked why Sverchok not works for me. Why this menu not working? Because you not entered in create new node tree. Then we make plane. Plane will be our generator of this field. Let's visualize this. So we've got some field. For example, we have we know the overall dimensions of the field, but we need to divide. Then we make number int and number float, starting with them. Making double, it will be x, it will be y, it will be x scale, it will be y scale, and we need number formula so that x will be divided on n for both cases. And first of all, we making, for example, 10 to 10, and limit parameters properties to minimum 2 and maximum 100. This minimum to a maximum 100, and scale from 1 to from 0, 1 to 3, 0, 1 to 3. Okay, now we have to connect this scale. Why I made 3 meters? Okay, maybe 10, and the overall scale. So if we this means we need or what? We need somehow no. Again, x is not that kind. So we need this dimension. For example, 3 dimension to be achieved by 9 items. So items have to be one less than this divider. So not here will be 1 plus, but here will be -1. I hope it will work. Yes, it work. Because of what? Because we have one segment and 2 points. If you have 2 points and one segment, you have to divider on bottom числитель знаменатель, то есть знаменатель reduced by 1. Oh, so then we scan for properties, can clean layout, and making some scales, some divisions, and maybe making some math to some math. First of all, vector out, vector in, and for z it will be math this direction, or better to make it complex, sinus x minimum of sinus x cosinus and it will be z. So it can be multiplier, number float, for example, will be multiplier as sinus of this value of x multiplied by n and 1 and the same and 1, so we can make this wave, and overall we can divide on n2. It will be second, it will reduce height of the dimension, this n plus n3, this will be high. So we height, I don't know, and this mode and this is multiplier, and this is divider, this is divider, and this is multiplier. So we have more complex objects, so we can define that kind of wave. And this simple thing, we can make multiplier for x and y separately, but not now. So we have some shape. I don't know what this part could be for you. This can be your manipulations, and so this can be your approach, this word. So you remember what we started from the scale, divided to this division number, but reduce it with 1. because of count of vertices and count of edges is different. So now we have make UV connect and join not deformed vertices with deformed. This will cut and join here. Not what we need. First of all, not need polygons, we need edges, and this case of this case will show us some tubes. So we have tubes, we can visualize them with pipe node, some modified, and size consists of 3 digits, x, y, and length. We can make 0.1 in length of 1. Length of 1 means that tube will go from bottom one point to another point, and the scale of this tube defined by this x and y of vector. We can plug this vector to show how it will work. So 0, 3, 0, 3 and 1, it will. So first of all, first and second x and y, it is units of Blender, and the third is the scale from point 1 to point last. It can be negative and can be positive, and more than one can be so extended. We need round peg, so make it round, and it will keep the bondings. We cannot cap, and this will make holes, but we need cap to visualize. So for example, you can plug for each tube and the peak on the peaks you can plug some, I don't know, sphere, for example. It's most simple. Making matrix scene to make objects, location, and making these polygons. It's long thinking, because much of vertices we can reduce to 8 to 8, and making, for example, 5. Its radius is not diameter as in tube. This is diameter of tube bondings, but this is not diameter, so we can plug one unit, one float for both, not here. We can plug this here, plug this here, plug this here, and call it tube. So we can define it from Sverchok 3D panel, and we can make different color. It could be something, I don't know where you can use this. So we may do something like this, and like this, and it will be some kind of your ceiling if you bottom, or to top. This can be seat or branch or something. You can join this plug on some plain bottom, or in concrete on or something. So to produce make this alive in real life, this additional values we can keep here, and to produce this is tubes, as we remember. Join, this is tubes, and this is spheres. I don't know, maybe not remember whether I vectorized here. Let's try. I don't remember really. I don't remember. Maybe from 0.1 to 0. Here, and what number of values we need. It is 1 multiplied 1 eaten with 1 with another float number float to int. It's better to do, because if we do something wrong here, we can check for whether it's what we need. Let's check. Here's a number 300. What number of edges we have? 300. So it fits one another, and we can join plug and check for whether it works. Check for another. Yes, it seems like it works, but let's more express this definition deviations. You can do not only this kind of job with tubes, but also not only series, but also attractor. So we can plug here an attractor objects and object in distance. This object will be cross, and let's matrix out, because it cannot recognize. No, but I have to do this. Cannot recognize one or another. So between this field and this point we find dimensions 300. We can see numbers at till 4. We can reduce this number with formula x dividing on 14 and make maximum of this value, or for example minimum tube we have 0.2. So, or we can how we roundify math. round n. This is round to 0.1, 0.2. It will not. Round n. Okay, now we have some kind of specification values with roundification, and we can join this to plug here, or reduce this value. No, better not to do here. This kind of maximum undefined. Why it not reduced? Why it not reduced? Why it not reduced? So we can limit this to 0.2, 0.3 and 0.4, three types of tubes. So we can see this point can make square. I will hide these circles to find if we need something to change. Here it is. Or it is better to keep this. We have 5, 4, 3, 2. 5, 6, 8, 7. So more items, but not so critical. We can do it. So to make a table, we can define this number first of all. Y's index. We can plug these items and show what we got. We're starting from this point. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, and we can check for text out node. Text out node, we need text file separated. Lengths will be the lengths generators scripted node. We have edge length scripted node, so we join from with this button imports, and here it arrives, and we plug this scripted node to this node. So we can use this UV connect. You remember here was lines, so we can find out what lengths are. Looking to script Sverchok viewer, we can see 300 values. We can plug here, and we can list split to define this split. This values splitted to the first x 10 item. Am I recording? Yes or no? Yes. Okay. So we can see whether we succeed with this 10 to 30, yes. Lengths. So we have nothing here till now, and we can define CSV format and Excel with tabs, with points and commas, and can dump this simple thing, but we're not in right things because we need to find out lengths. Let's clear edge length, join, plug this edge length because we spoiled this text. Let's say we need to see this dump length dump. Here we have. It can be used already, but export is save as length desktop length CSV. We can this length use it, and or we can plug also these rounded rounds, but I will create lengths and diameter CSV, and we will make one column with length, another column with these diameters, and we will dump with length diameter Excel and dump. So we can save text, save as desktop diameter. Now we can diameter is open, and we can see it not recognized because something went wrong. I don't know why. Maybe try dump this and text save text save as desktop save enable because it open. Yeah, text save. Okay, save. We open again, and it will not work. I don't know why. Maybe we need to remove it and yes, paste. I don't know why it happened. But we have table with defined these rows, and we can check for this length. It will not help because the same Excel tabs. Let's make tabs not okay. It seemed to work. Paste, copy paste working, but something with these things I need to remove them. Removed, paste, okay. it's not right, but it works. So we can export this table to cut tubes for our needs, or we can make more complex maybe table. This split will split later. We can list zip this and this. We can check for what it is. This and this. This and this not worked somehow. Let's check again. Values. Zip have to work. Okay, it works. It works, and we have couples of this thing. We can try this 10 to 10 to 10, and we can try length dump. Maybe it will work. No, it doesn't. But we can or we cannot. We can work on this, but simply we can use lengths and this radius and diameters to make real tubes, make them unified, or reduce this number of deviations and abundance this diameters. Maybe it can help someone. And then we can make assembly layout to workers who will make these tubes in life. So we can these numbers only bake. We have this node show you bake in right properties panel and press. We have no fonts, but press bake. Okay, show now, and every individual can be or cannot be we just can bake also these tubes, and we lost the blender. Okay, this assembly can be done anyway. So in this lesson we investigate how to crush Blender with Sverchok and how to make tables. Thank you, goodbye.